Okay, so the question is maximum total from optimal activation order. Okay, you are given two integer arrays values and limits. Okay, let me first also start the timer. Arrays values and limit, both of length n. Initially, all the elements are inactive. You may activate them in any order. To activate an inactive element at index I, the number of currently active elements must be strictly less than limit of I. When you activate the element at index I, it adds value of I to the total activation value, the sum of value I. For all elements that have undergone activation operation, okay, add value to the total activation value. Activate an element. After each activation, if the number of currently active elements becomes x, then all the elements j with limits of j less than equals to x become permanently inactive, even if they are already active. Okay. Return the maximum total you can obtain by choosing the activation order optimally. Okay. Input value is 358. Limit is 213. Hmm. So basically, we have values and the limits. So the number of currently active element must be the number of currently active elements must be little less than the limit of I. Okay, at a time we can have this many order permanently inactive, they're already active. Okay. First of all, we need the number to be strictly less than the limit to activate it. It adds value of I to the total activation value. The sum of the value of I for all the elements undergone activation operations. After each activation is the number currently after each activation, if the number of currently active element becomes x, then all the elements j with limits of j less than equals to x becomes permanently inactive. Number of currently active elements becomes x. What is x? Then all the elements with limit j less than equals to x. Okay, this is a new value we need to keep on computing. Permanent active. Is it already activated? The maximum total you can obtain by choosing activation order optimally. One optimal activation order is step 1 activated I is 1. Okay, so first of all we went to 1. The value of I is 5. Active before I is 0. Active after I is 1. Becomes inactive. J equals to 1 as limit of I equals to 1. Inactive elements is 1 and total is 5. Hmm. And I, it adds value to the total activation value. I, the sum of value of I for all elements that have undergone operation. The number of currently active elements must be less than the limit, not the value. So the number of currently active elements is 0. So this is valid. Now the number after activation, the number of currently activation is 1. All the element j with limit j less than equals to 1 should become inactive. So why 1 became inactive? They are already active. Maximum total order is going to be just the value. This is fine. Step 2 is activated 0. 0. Value of I is 3. Active before is 0. Active after is 1. Is limit of I equals to 1. Okay, all the elements with limit of I less than equals to x. X is 1. After activation, the value of x is 1. So all the elements with I less than equals to 1 will become inactive. Only one became inactive. One is inactive. Total is now 5. Step 2, we are gonna choose any item. The value is 3. Active before is 0. Active after is 1. Now 2. All the element whose value is less than equals to 2, limit I less than equals to 2. Why isn't it activated? 0 is activated. हाँ 5 plus 3 8 तो हो गया. But it is 1. Okay, after an active element, x is okay. This is the value active after is x. So no one will get inactive. Okay, 8. Now 3, we have activated index 2. Its value is this. Active before is 1. Active after is 2. Now all the elements. Hmm, hmm. Now all the elements where the activated value. All the elements where the activated value. Okay, after addition 2 is with where the limit is less than equal to 2. We have 0 and we have 3 now. Limit of 0 is less than equals to 2, so it will get inactive. This is it. Hmm. Okay, we can make inactive even if they are already active. So this criteria will apply to everyone, not just the one of the operation order is activated 2. First order activated 2, value 6, before 0, after is 1. Now all the value less than equals to 1 will get inactive. To limit, we need to sort. Sorting, will it work? Okay, limit 1 1 1. And based on this limit, we can have values. So all will get inactivated. Next one is 4152. Limit is 3323. So the order is it minimum? First we have to choose the least value of the limit. 1, then 2, and then 3. Why? So we'll have to sort it by limit. First I'll choose 2, and then before activation 0, after activation 1. Inactive elements will become blank. We have a 5. Then I can choose any one because all of them have the same value. Does it need to be sorted by this also? 0 1 2. Let's give it. 0, 1, 3. You can have it sorted by limit. So minimum value I'll pick 2 and then I'll have 3, 3. Once they are marked as inactive, I will not pick them. Hmm. Okay. So I need to create limit in a sorted order, and whenever I'll get an element, the least element I'll pick. Okay. Let's say I picked this one. I picked any one of them. The value will get added. Okay, that will not be enough. I'll pick the value as 2 before activation 0, after activation now it's 1. Now all of them will become inactive. All of them will become inactive, and the total will only be 2. I'll have to maximize the value while minimizing limit. Is it? So sort by limit in descending order. Choose the minimum limit, and if the limits are same, then choose the maximum of the limit. So let me just add a note here. So 358 is there, and 213 is there. Okay. So the limit is, if I sort it by limit, it's gonna be 1, 2, 3. And it's gonna be 5, 3, 8. Okay. Now, okay. 1, 2, 3, and then this is 5, 3, 8. So the minimum is 5. Okay, the minimum is limit is 1 and 5. I'll pick this. I'll have a value as, okay, before activation is 0. After activation, I'll have activation value as 1. Now, so least, okay, j less than equals to x. इसका भी लिमिट लेस देन इक्वल टू x सबको रिमूव करो, and there is only one to be removed. तो यहाँ से आ जाएगा yes. I'll remove this item. And total sum will become 5, where initial total sum was 0. Okay. Next, I'll go to step 2. I'll again pick the minimum of this. That's gonna be 3, value 3, index 1, and value activated index is this. I'll pick this. The value will get added. It will become 8. 8, and after activation it will be reduced to 0, and then it will become 1. All the items which has value limit less than equals to 1 will get, there will be no one, so it will stay put at 1. Now I'll go to in next pick, and this is removed. I just have 3, 8. I'll pick 8. So it will become 8 plus 8, 16. Hmm. Okay, that was still part. Okay, once you pick, you don't have to remove it. So it was 2, 3 and 3, 8. It was there active. It's not inactive. Okay. So it's not necessarily to remove that. It's not removed. Huh. I picked now. What will I pick? I picked 2 and 3. Limit. Min limit will I picked. If I will not remove, I'll not be able to get the next item. But you don't have to remove it. Hmm. Can you keep on picking the same number? 2, 3, then 3, 8. Hmm. Actually, you can pick. It adds value of I to the total order activation. Column item under an active operation. Hmm. So we are not removing the item. Activated is there. It is still. It's not inactive. It can be picked. Hmm. What if I pick the item? Can I pick? So I have made this element as active. If I choose the same item again, it will keep on adding to. Can we repeat activation of the same numbers? No. So we can have run the maximum possible as 12. 2 3 3 3 में सबसे बड़ा कौन सा है? जैसे 5 is it? नहीं 4 4 this is just not required. If I make an item inactive, you can activate in order to activate an element. The number of currently active elements must be less than this. Number of currently active. When you activate an element at an index I, it adds the value to the total activation value, the sum of the value for all the elements that run activation operations. After if the number is currently active, if the number of currently active elements become x, then all the element j with the limit less than equal becomes inactive. Obtained by choosing activation order optimally Okay, we are asked to choose the activation order optimally, means we have to always choose the activation order such that maximize the value at any point of time. Optimal picking is I need to maximize my sum. If I keep on picking the same item, I might lose out on that because all the elements with say limit less than equals to x, my x will sooner or later it will become greater than limit of the maximum element without even adding the value. Okay. Okay. So which data structure will I use? Min heap sorted by this and then this. So I'll have to create a node first or a 2D. I'll have to convert it into a 2D array with limit and value linked. Every time I'll pop them out one by one and I'll keep an after activation number and then I'll check if the limit is less than equals to x and I'll just keep on removing them by marking them inactive. Okay, let me start using the priority queue. Okay, I'll also have to add the comparator for this. That is gonna be a comma b is gonna do such that if a of 0 is not equals to b of 0, I'll just return integer dot compare a of 0 comma b of 0, else return on the basis of second one. So first it will be sorted by limits and then value. First is limit and then second is value in the array. And I'll just add there we go. Items are added. Now I can keep on running the loop while my priority is not empty. Right, all the elements are not activated. And then okay, I'll just do a pq.poll. I need the element anyways. To first of all, I'll require it. Current is gonna be this. Okay, I'll and maintain a long sol equals to 0. Initially there are no items, and active is equals to 0, no activations. Yeah, that is all. This is activations. Cool. I'll just mark my active as plus plus. Now all the items whose limit is less than active, again, while pq dot peak, is there a peak? Not sure. Peak of limit is less than active, less than equals to active. I'll just hold them. Hmm. All the elements. Hmm. Hmm. Inactive. क्या हुआ था? 0 after activation I got 1. 1 after activation I got 2. And how many? Okay, if the same element j equals to activated, if the one which is activated is the part of, okay, I'll also have to check for the current item. So all the other items are marked as inactive, so they will not be considered in the solution. But the one which is active, if that same number is deactivated, 0, 1, and 3 is marked as, okay, 2 was already removed, 3 only one of them, so my inactivation. So every time I'll just do this check. If curve 1 current of 0 is also less than equals to active, I'll do active minus minus. Only in this case my active will reduce, otherwise it will stay put. Okay, ठीक है. This is another while loop activation. Total value is something we're gonna take every time as solve plus equals to current of 1. That is just gonna get added, and this will remove from the item list, so it will not even be considered, right? Okay, figure it not empty. Hmm. Okay, second one I'm getting an incorrect answer. What is the value I'm getting? Okay, value. So first it should be sorted by a of 0, that is limit. If the limit is okay, if the limit is not same, then I'm comparing with value. Acha, value has to be reverse order. Okay, yes, that's correct. 12, 11, 12. Hmm? So first it will pick the least value 2, and my after before activation is 0. After active will become increased, and then solution will become 5, while peak is empty नहीं है, not empty, and peak at peak of 0 is less than equals to active. Active is 1, peak is gonna be 5, so it's not less than empty. We go to the next, and okay, not 5, 4. So the next it will pick 4. So that's 4. Uh, okay, I'll have to keep a set of activations also. Then only I can reduce active. No? Okay, I'm only reducing it here. I think I should put them in one more sorted. In one more priority queue PQ, which will contain active items. So I can always have a. So this one will not work. I'll have to create one more priority queue. Active. Okay. Here हो गया. C plus plus PQ active dot add. PQ active dot add. Okay, so I added it to the active item. Okay, this is there. Another thing that I need to check, while PQ active is not empty and PQ active dot peak of 0 is isn't active, in that case I'll do this and also reduce my active. This one is removed. It's not even active anymore. And active plus plus is not needed. Active dot length is fine. Hmm. Really? Mm-hmm. Okay. I think okay, this is solved, but the time complexity and space complexity are way too bad. Let me try to optimize it. Okay, it took me 34 minutes also. That's the bad part. Okay, anyways, uh, what I can do to optimize the time. With the current time complexity is basically big O of n only, because I'm iterating all the items at once. I'm moving it to active set, and then I'm again removing the items from the PQ active if it's uh, approaching the set limit. Yeah, so it's big of n only. Can I do it in log time? I think if I can maintain a list as a 2D, like a sorted list, and then I'll start from the minimal value. Uh, okay, let me check the hints. Wait, PQ active and PQ. Optimizations. Should I check the hints now? 20 per 5, so it's working, but it's not the best solution yet. Two, two, two. Hmm. Do I need priority queue to keep all the active elements? Because after the first iteration, I only need to check the limit. I don't need to check the value. The second one can simply be put in a no sorted under the item to be sorted in. Yeah, only by limit is needed. I can improve that, but that won't make a big difference. If I just, rather than keeping int array, I can just keep integer for the limits, sorted by limits. Y and B, only N B is enough. Limit, limit. Only limit is needed, right? Yeah, I'm just doing pqactive.peak. Then pqactive.peak is less than equal to, just don't pull it. Then this might reduce the space a little. It's not even an optimization. Space. How can I reduce the space? By not using priority queue, maybe. Some possible value is 12. Hmm. Okay, let me check the hints. Limit values as decision for each limit are independent. For a group with limit j and m items, its contribution is the sum of top j, m values Extract each group's top value. Use a min heap's j capacity to push div whenever the heap size exceeds j. Pop the smallest. After proceeding groups heap, sum its element and add to the overall total. Repeat for all groups in any order. Okay, I could have done it using a single heap and then grouping it by map, I guess. Fine, anyways.